A room with a significant amount of pure oxygen contained within pipes is considered a hazardous location as per the National Electrical Code. Section 500.8b of the NEC defines a Class I, Division 1 hazardous location as an area where ignitable concentrations of flammable gases or vapors can exist all the time or some part of the time under normal operating conditions. Pure oxygen is a strong oxidizing agent that can greatly accelerate the combustion of any flammable materials. Therefore, a room containing a significant amount of pure oxygen is considered a Class I, Division 1 hazardous location. Several specific sections of the NEC cover hazardous locations with pure oxygen, including Article 500, which provides general requirements for electrical installations in hazardous locations. Section 500.7 covers the classification of hazardous locations. Section 501.15 addresses equipment approvals for Class I hazardous locations. Section 501.30 specifies wiring methods for Class I hazardous locations. Section 501.110 covers sealing and drainage for Class I hazardous locations. The magnitude of oxygen present in the pipes in the room, fed from a 20 megawatt oxygen plant, suggests that this is a very hazardous location. Extreme care must be taken to ensure that all electrical equipment and wiring in the room are approved for Class I, Division 1 locations. Firstly, provide ventilation to prevent the accumulation of oxygen concentrations above 23.5%. Secondly, implement a rigorous maintenance program to inspect and test equipment regularly. Thirdly, develop and implement emergency response procedures in case of a leak or fire. Let's delve deeper into the relevant sections of the National Electrical Code to understand the requirements for electrical installations in oxygen-rich environments. Article 500 provides the overarching guidelines. It sets the stage for ensuring electrical safety in areas where fire or explosion hazards may exist due to the presence of flammable gases, vapors, liquids, combustible dusts, or ignitable fibers or flames. Section 500.5 specifically classifies hazardous locations based on the properties of the flammable materials that may be present and the likelihood of their presence. The NEC divides hazardous locations into classes, divisions, and groups, each with specific requirements for electrical equipment and wiring. In our case, with the presence of pure oxygen, which enhances combustion, the area is classified as Class I, Division 1. Class I locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 locations are those where the hazardous material is present under normal operating conditions, where it is frequently present because of repair, maintenance, or leakage, or where faulty operation of equipment might release hazardous concentrations. Section 500.7 details the area classification requirements, including competent personnel determining the classification, documentation, and classification markings. Section 501.15 focuses on equipment approvals. It mandates that all electrical equipment installed in Class I hazardous locations must be specifically approved for the class and division of the location. This approval signifies that the equipment has been tested and certified by a recognized testing laboratory to be safe for use in the presence of flammable gases or vapors. Equipment used in Class I, Division 1 locations is typically explosion-proof. This means that the equipment is designed to contain any internal explosion without igniting the surrounding atmosphere. The equipment must also be designed to prevent arcs, sparks, or hot surfaces from igniting the hazardous material. Section 501.30 outlines the acceptable wiring methods for Class I hazardous locations. These wiring methods are designed to prevent the ignition of flammable gases or vapors due to electrical faults or arcs. Some common wiring methods for Class I, Division 1 locations include rigid metal conduit with threaded fittings and cable with a gas-tight continuous sheath. All conduit and cable entries into explosion-proof equipment must be sealed with an approved sealing compound to prevent the passage of flammable gases or vapors into the equipment. Section 501.110 provides requirements for sealing and drainage. Sealing is crucial to prevent the migration of flammable gases or vapors from one area to another through conduit systems. Seals must be placed at specific locations, such as where conduit enters explosion-proof enclosures and where conduit crosses boundaries between hazardous and non-hazardous locations. Drainage is also important to prevent the accumulation of liquids inside conduit systems. Conduit systems should be designed to slope away from equipment enclosures to allow liquids to drain out. In addition to these specific NEC sections, several other considerations are important for electrical safety in oxygen-rich environments. Proper ventilation is essential to prevent the accumulation of oxygen concentrations above 23.5%. This can be achieved through natural or mechanical ventilation systems that continuously circulate fresh air into the area. Regular maintenance and inspection programs are crucial to identify and correct any potential electrical hazards. These programs should include visual inspections, electrical testing, and thermographic surveys to detect overheating components. Emergency response procedures should be developed and implemented to address potential leaks or fires. These procedures should include evacuation plans, fire suppression strategies, and first aid protocols. All personnel working in oxygen-rich environments should be properly trained in electrical safety and emergency response procedures. Training should cover the hazards of oxygen-rich environments, the proper use of electrical equipment, and the procedures for responding to leaks or fires. It is important to consult with qualified electrical engineers and safety professionals to ensure that all electrical installations in oxygen-rich environments comply with the NEC and other applicable codes and standards. These professionals can provide guidance on the selection, installation, and maintenance of electrical equipment and wiring. They can also help to develop and implement effective safety programs and emergency response procedures. Furthermore, consider the specific properties of the oxygen being used in the process. While oxygen itself is not flammable, it acts as a strong oxidizer, which significantly enhances the flammability of other materials. Therefore, materials that may be considered non-flammable under normal atmospheric conditions can become readily ignitable in an oxygen-rich environment. This includes some metals, plastics, and even certain types of clothing. Ensure that all materials used in the oxygen-rich area are compatible with the environment and do not pose a fire hazard. This may require the use of specialized materials that are specifically designed for use in oxygen-rich environments. Another critical aspect is the control of potential ignition sources. In addition to electrical equipment, other potential ignition sources include open flames, hot surfaces, and static electricity. All potential ignition sources should be eliminated or controlled to prevent the ignition of flammable materials. This may involve implementing strict policies regarding smoking, the use of open flames, and the use of non-approved equipment. Static electricity can be controlled through grounding and bonding techniques, as well as the use of anti-static clothing and footwear. Moreover, consider the potential for oxygen leaks. Oxygen leaks can create localized areas with very high oxygen concentrations, which can significantly increase the risk of fire. Implement measures to prevent oxygen leaks, such as regular inspections of piping and equipment, the use of leak detection systems, and the implementation of strict maintenance procedures. In the event of an oxygen leak, immediate action should be taken to isolate the leak and ventilate the area. Emergency responders should be equipped with self-contained breathing apparatus to protect themselves from the high oxygen concentrations. Finally, remember that electrical safety in oxygen-rich environments is an ongoing process. Regular monitoring, inspection, and maintenance are essential to ensure that electrical systems continue to operate safely and effectively. Stay up to date on the latest codes and standards, and continuously evaluate and improve safety procedures. By following these guidelines, you can help to minimize the risk of electrical hazards and ensure the safety of personnel and equipment in oxygen-rich environments. The National Fire Protection Association, or NFPA, also provides valuable guidance and standards related to fire protection and electrical safety. NFPA 70, the National Electrical Code, is the primary standard for electrical installations, but other NFPA standards may also be relevant to oxygen-rich environments. For example, NFPA 50, standard for bulk oxygen systems at consumer sites, provides requirements for the design, installation, and operation of bulk oxygen systems. NFPA 70E, Standard for Electrical Safety in the Workplace, provides requirements for protecting employees from electrical hazards. Consulting with NFPA experts and reviewing relevant NFPA standards can help to ensure that electrical installations in oxygen-rich environments meet the highest standards of safety. Understanding the specific hazards associated with oxygen-rich environments is crucial for implementing effective safety measures. Oxygen is a powerful oxidizer, meaning that it readily supports combustion. In an oxygen-rich environment, materials that would normally be difficult to ignite can become readily flammable. The higher the oxygen concentration, the easier it is to ignite materials and the faster they will burn. This can lead to very rapid and intense fires that are difficult to extinguish. Furthermore, oxygen-rich environments can increase the risk of explosions. Flammable gases or vapors that might not explode in normal atmospheric conditions can explode violently in an oxygen-rich environment. This is because the increased oxygen concentration provides more fuel for the explosion, resulting in a larger and more powerful blast. The properties of the materials being used in the oxygen-rich environment should be carefully considered. Some materials that are normally considered non-flammable can become flammable in the presence of high concentrations of oxygen. This includes some metals, plastics, and even certain types of clothing. Materials that are known to be flammable should be avoided whenever possible. When flammable materials must be used, they should be handled and stored with extreme care. The design of electrical equipment for use in oxygen-rich environments requires careful consideration. Equipment should be designed to minimize the risk of ignition. This includes using explosion-proof enclosures, limiting surface temperatures, and preventing the formation of arcs or sparks. Equipment should also be designed to withstand the corrosive effects of oxygen. Oxygen can react with some materials, causing them to degrade over time. Therefore, equipment should be constructed from materials that are resistant to corrosion. The installation of electrical equipment in oxygen-rich environments should be performed by qualified personnel who are familiar with the specific hazards of these environments. All equipment should be installed in accordance with the manufacturer's instructions and applicable codes and standards. Wiring should be properly sized and protected to prevent overheating and short circuits. All connections should be tight and secure to prevent loose connections and arcing. Regular maintenance and inspection of electrical equipment are essential for ensuring continued safe operation. Equipment should be inspected regularly for signs of damage, wear, and corrosion. Any damaged or worn equipment should be repaired or replaced immediately. Electrical testing should be performed periodically to ensure that equipment is functioning properly. Safety procedures should be developed and implemented to protect personnel from the hazards of oxygen-rich environments. These procedures should include training on the hazards of oxygen, the proper use of electrical equipment, and emergency response procedures. Personnel should be required to wear appropriate personal protective equipment, such as flame-resistant clothing and eye protection. Smoking and the use of open flames should be prohibited in oxygen-rich areas. Emergency response procedures should be in place to address potential leaks, fires, or explosions. These procedures should include evacuation plans, fire suppression strategies, and first aid protocols. Emergency responders should be properly trained and equipped to handle emergencies in oxygen-rich environments. In conclusion, electrical safety in oxygen-rich environments requires a comprehensive approach that includes careful design, installation, maintenance, and operation of electrical equipment, as well as the implementation of effective safety procedures. By following these guidelines, you can help to minimize the risk of electrical hazards and ensure the safety of personnel and equipment in these challenging environments. Remember to always consult with qualified electrical engineers, safety professionals, and relevant codes and standards to ensure compliance and best practices. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice.